Let's look at another example. So you're going to soccer practice and you really love being goalkeeper, but it depends on who the coach is, and you're trying to figure out what's your probability of becoming the goalie. So if Sam is the coach, the probability of being the goalie is zero point 0.5. If Alex is the coach, the probability of being the goalie is zero point 0.3. So what we know is that being goalie and having a certain coach are not independent events, right? Because if Sam is the coach, you have a different probability of being goalie than if Alex is coach. So they are not independent. Who the coach is and whether or not you're a goalie are not independent events. Okay. Sam is the coach more often though. So in 6 out of 10 games, Coach Sam is the coach. And then, so that would mean 4 out of 10 games, Alex is the coach. So you have a 60% chance of Sam being the coach, 40% chance of Alex being the coach. So we can draw a tree diagram to show that. And we can show that there's, here you are right there. And you're going to go play some soccer. And you have a 60% chance of Sam being coach and 40% chance of Alex being coach. Now, if Sam is the coach, what's your chance of being goalie? So we're going to extend our tree diagram. If Sam is the coach, your chance of being goalie, yes, being goalie is 0.5%, and no being goalie is 0.5% as well. But if Alex is the coach, you have only a 0.3% chance of being the goalie and a 0.7% chance of not being the goalie. So we have to calculate the overall probability of you being the goalie. So let's just calculate the probability of every single branch. Okay, so what is the probability of Sam being the coach and you being goalie? So this is, Sam, and yes. Okay, so what's the probability of that? And instead of writing that and like that, I should probably write our actual like mathy and. Okay, so what's the probability of that? Well, we multiply, right? So 60% of the time you get Sam as the coach, and 50% of that 60% you get to be goalie. So this is going to be 0.3% of the time. We multiplied 0.6 times 0.5. So that's going to be the same thing because your chance of not being a goalie with Sam is the same as being goalie. Now with Alex, it's different. So you're going to have 0.12% chance of being goalie and a 0.28% chance of not being goalie. Now, if we did this right, these should add up to 100%, right? Because you have a 100% chance of one of these things happening. Either Sam is the coach and you are goalie. Sam is the coach and you're not goalie. You know what I mean? Like all of these have to happen and they have to add up to 100%. So let's see if they do. You have 28 and 12 is 40, and then another 60 is 100. Perfect. So they do add up to 100%. So what is the probability? I've got it all just kind of, shown out here, highlighted. This is the chance of, yes, you being goalie. If Sam is the coach, we have a 30% chance. But we have to also calculate the probability for what happens if Alex is the coach, right? Because you have a 30% chance with Sam, or you have a 30% chance of Sam being the coach and you being goalie. But then you also have a 12% chance of Alex being the coach and you being goalie. So what is your probability altogether? Well, we can add those together, right? Because you have a 30% chance that you're going to be coach or you're going to be goalie with Sam, and a 12% chance that you're going to be goalie with Alex. So you actually have a 42% chance overall of being goalie because you're looking at this or this happening, right? So this branch happening or this branch happening. We're trying to figure out what happens if either one of those happens. We can also use this for non-independent events. So remember that like if you pick a card and it's independent, you could just say like this is 26 out of 52, and then this is 26 out of 52, and then 26 out of 52. But we can use tree diagrams for non-independent events as well. In fact, they're really, really handy for non-independent events because we can show different things. And we kind of showed this at the very beginning, so I won't go too far into it. But the first time I pick a card, the chance of it being black or red is 26 out of 52. Like I have a 1/2 chance of being black and a 1/2 of a chance being red, right? But the second time, if I pick a black card the first time and I don't put it back, I only have 51 cards left and only 25 of them are black. So because the one black card is already gone. So I only have a 25 and 51 chance of picking a black but I have a 26 in 51 chance of picking a red. So if I'm trying to find the probability of picking a black, I can multiply 26 over 52 times 25 over 51, and I can get this, and in all practical senses, we would just use a calculator for stuff like this. I probably would never ask you to do this as a fraction with these big numbers, but you would just multiply, and you get about a 24.5% chance of getting black. And then we could multiply here, 26 over 52 times 26 over 51 would be a 25.5% chance of getting black, red. And so then we have the same, we can just go through, and then if we added those together, we would find that they added up to 100%. So these are our percentages. Remember, we just multiply through the tree diagram. So here we've got another example. A bag contains 3 black balls and 5 white balls. Paul picks a ball at random from the bag and then replaces it back in the bag. Then he mixes the balls in the bag and then picks another one. So what is the probability of him picking certain things? So first we have to construct the tree diagram, and you can see that here we construct it. The very first time he pulls a ball out of the bag, we have a 3 in 8 chance of it being black and a 5 in 8 chance of it being white. Then the second time he draws, we have a 3 in 8 chance of it being black and a 5 in 8 chance of being white because we put the ball back in, right? So here's our outcomes. Our first outcome would be that we drew a black, okay, and that would be 3/8 times 3/8. Our second outcome would be black, white, which is 3/8 times 5/8. And white, black, which is 5/8 times 3/8, and then white, which is 5/8 times 5/8. So these are our different probabilities of getting each thing. And so if we wanted to answer these questions, what's the probability that he picks 2 black balls? Well, that would be 9 out of 64. What's the probability that he gets a black ball on his second draw? That's going to be a little bit different because there's a couple options, right? This one right here, the probability of picking black is 9 out of 64. And that has a black on the second draw. But guess what? This one also has a black on the second draw. So we're looking at both of those probabilities together. So we're looking at what is the probability of this one happening or this one happening. So we're going to have 9 over 64 plus 25 over 64, which is 34 over 64. Oh, I can't talk and write at the same time. 34 over 64. That's our probability of getting a black on the second draw.